To finish up this thrilling episode, I know you're loving it, we are going to talk about the London Eye because, it's the London Eye. It's super cool. Also, because you will have some modeling problems where it'll be word problems and they'll seem super complicated, but it's literally just what we did. You just might have to draw some diagrams, so I'm going to show you some examples. In fact, everything on your homework should be a sine or cosine wave in these modeling problems. So we got the London Eye here. So Jacob and Emily ride the London Eye together, which is precious. The wheel of this eye is 394 feet wide, and the whole structure is 443 feet tall from its base. So from the very bottom. When I say base, we're talking about the ground. And it makes 2 revolutions per hour. I do want to make note right here, because later on we're going to have t in minutes. Let's go ahead and note that 1 revolution is going to be 30 minutes. That'll be important. So let's actually draw a quick diagram, because this kind of doesn't make sense. If we have a wheel, you would think the wheel should be circular, not oval. So why are there 2 different values right here for this wheel? Why is it 394 feet wide, but 443 feet tall? Well, let's draw a picture and get an idea. So when you have a Ferris wheel, like the London Eye, you do have a base. So when we say it's 394 feet wide, we are talking about the diameter. But when they talk about the height, they're including the base with it. So it's 443 feet. So we need to find how far off the ground our London Eye, our Ferris wheel is. So if you go ahead and take 443 and subtract it from 394, you'll find that this whole Ferris wheel is 49 feet above the ground. Now they're asking us to write an equation for the height in terms of the time t in minutes, given that Jacob and Emily are at the lowest point at t equals 0. I know you probably checked out as I read all of that. So our lowest point is at t equals 0. So we're starting right here at the lowest point on the Ferris wheel. And we just want to represent the height that they're at. So if you think about this, full revolution after 30 minutes, I'm going to go ahead and, easiest way for me to figure this out is actually just draw a really rough sketch. So at time 0, we're going to be 49 feet. So this is going to be our height in feet. And then the x-axis will be our t, time in minutes. Okay. So we're going to be right here, 49 feet. And 30 minutes later, by the way, no joke, this is for real. Look it up on Google. It takes 30 minutes. Google knows everything. So 30 minutes later, you are 49 feet above the ground because you've finished your whole ride. So that would mean that after 15 minutes or halfway through this cycle, I'm going to be at the very, very peak. So I'm going to be at some peak. And that peak, since the whole structure is 443 feet, will be 443 feet. So you got your mins, you got your max. You can kind of guess that in between all this is a circle after all, everything in between, if we found everything in between, it's going to look like a cosine graph because we're going to start at a minimum, go to a max, and go back. Which means, just like we've done, we are going to go ahead, there we go. We're going to go ahead and model a cosine graph. So no different than what we've done. Meaning we've got to find our amplitude, our midline, our period. We've got to map this whole thing out. I know we love it. Now, the easiest thing for us is the period. They told us 1 revolution is 30 minutes. Okay, so that means to find our b, you do 2 pi divided by 30, which is pi over 50. Okay, midline, this is where I told you my little trick is going to help us. Our highest point is 443 and our lowest point is 49. So if I take 443 and add it to 49, then divide by 2, I'm going to find the midline, which, by the way, on your homework in some of these word problems, they won't call it the midline. They'll sometimes call the midline the average. If you see the word average, it means the same thing, that they're asking you to find the midline. Okay, so take note of that. So if we average these, so 443 plus 49, divide that by 2, I get 246 feet. And then amplitude, if you recall, I just said to take your max number and subtract the midline to find your amplitude. And I get 197 feet. Let's work our magic. So to write our equation, which by the way, they want it in terms of h, so I'm going to write h instead of y, and we're going to use t instead of x, but otherwise everything else is the same. So amplitude is 197, so we're going to go ahead and put the 197 right here. And since we're starting at the minimum, we're going to put a little negative there. And we've got cosine, and we're going to use a t instead. And we found our b, so it's pi over 15. So that's this right here. Boom. And then our midline is 246. So I'm going to put that right there. So I'll just put plus 246. And you are good to go. That is the equation.